say what the difference is, what's changed over the last 30 years or so. And so for those who don't know, the original Ethernet was a coax-based system. It used a 75 ohm, 0.405 inch outside diameter coax, and had transceivers clamped onto it. And then there was a twisted pair drop cable that went to the computer in various people's offices. The 10 megabit, that network started out in 1973. The Ethernet standard, DEC Intel Xerox, came out in 1980. It also used a same diameter cable, but 50 ohms, and transceivers with a drop cable. This was used in the industry. The setting were typically buildings where they could run the cable through the ceiling of the building and have the drop cables. That was the market for research lab. But as it moved into the office environment, things changed. People had what's called star wiring, where the wires went to a wiring closet. So this linear bus that was daisy-chained through the building no longer applied. So that resulted in the twisted pair Ethernet. So that was an evolution that we had. And we had an intermediate step, by the way, where we went to what was called thin Ethernet. It's a 0.195 inch outside diameter. That's the RG58 AU coax cable, which you could plug BNC connectors on. And that was wired up to T connectors that plugged into the back of network adapters plugged into IBM PCs. And that persisted up to about 1987 to 1988 time frame, at which point twisted pair Ethernet started to emerge, which allowed people to use RJ45 connectors and 100 meter runs from the desktop to the wiring closet. The IC technology that people made the controllers out of changed over this period of time as well. From the very early days where the mini computer controllers were filled with IC chips, TTL IC chips. So these were packages that, for those who haven't seen it, they had maybe 7 or 8 leads on a side, and the rows, 2 rows of leads, about 3/10 of an inch apart. And they only had maybe 4 NAND gates in them, or NOR gates, or a couple of flip-flops. And from 1980 to 87, moved to integrated circuits that implemented much of the controller and the bus interface logic. So, for example, the products from 3Com had a bus interface gate array and an Ethernet controller chip, and then a separate transceiver chip. So that would fit onto about a half-length card for an IBM PC. Through the 90s, all of this stuff got integrated into a single chip, and the adapter by the late 90s had got to the point that it was about this much above the height of the edge connector. And it had to be the width of the edge connector because you had to plug all the pins into the bus into the PC. So there was miniaturization. In the early 90s, we moved toward standardizing for 100 megabits, and that standard came out in 1995. The size continued to go down. The original mini computer controllers of 1980 vintage were of the order of $2,000 or $3,000 each, without the transceiver. When we introduced the controller for the IBM PC in 1982, September, it was $950. This was a board that included the transceiver. I'll just hold it closer. Is that better?
That's good.
Oh, okay. So by 1982, we were under $1,000. By the late 90s, we were down in the $10 range for a controller if you bought them on sale at Fry's Electronics. This was an electronics store in the Silicon Valley area that has lots of, where you could buy lots of different parts, as well as computer equipment. And we've continued to move from the 100 megabit to now where you have motherboards that have 10, 100, 1000 right on the motherboard. The thing that has stayed constant as was just mentioned with Ethernet, the packet format is the same. In the original Ethernet, the hardware implementation, if you looked at it with an oscilloscope, on the coax cable, you literally just saw the packet. It was the purest form or hardware implementation of a datagram. You had a preamble bit, destination and source addresses, the data field, and a CRC. You still find those today in an Ethernet packet. So those are the changes from the, and we've continued to move from the from 100 up through a gigabit, and now on our way to 100 gigabits. Let's see. Oh, and one other change. In the early days, Ethernet was in effect a half-duplex medium to share the use of the coax. From 10 base T forward, the transmission medium has been full duplex. The implementations up until the mid-90s were mostly half duplex. That is, in a repeater, they would have perhaps 10 or 20 ports on a repeater, but the repeater only gave you the total aggregate bandwidth of a single network segment. With the lowering cost of silicon, in the middle of the repeater they embedded a piece of switch silicon rather than a piece of repeater silicon. That allowed you to have a total aggregate bandwidth equal to the network data rate times the number of ports on the hub. Clearly a big advantage for the users. So that's the other change that has happened. But the packet format remains the same, and the primary goal is to provide a very cost-effective and good performance communication medium. That's all.